Hi class, how are you today? That's great! The learning target for today is to categorize and identify parts of statistical studies. The scale, you're a 3 if you can categorize and identify parts of statistical studies. 2, you can categorize and identify most parts of statistical studies. 1, you can categorize or identify some parts of statistical studies. And 0, you cannot categorize or identify parts of statistical studies. Let's get started. Chapter 1, Getting Started. Section 1.1, What is Statistics? So for this section, here are some focus points. We're going to identify variables in a statistical study. So if you're given a study, what are the variables? You're going to distinguish between quantitative and qualitative variables. Are the variables you're looking at quantitative or qualitative? You're going to identify populations and samples. You're going to distinguish between parameters and statistics. You're going to determine the level of measurement, and you're going to compare descriptive and inferential statistics. Introduction. Statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. So statistics is really just taking data and doing stuff with it. It's analyzing data and figuring out what the data means and how we can use it. Individuals are the people or objects included in the study, and a variable is the characteristic of the individual to be measured or observed. So the individuals are the things being studied. The variable is what about those things are we studying. So for example, if we want to do a study about people who've climbed Mount Everest, then the individuals of the study are the people who've made it to the summit. Variable could be many things. It's what do we want to know about those people who have made it to the summit. So some examples might be age, weight, gender, nationality, income, so on. It's whatever you want to study about these people that have made it to the summit. Regardless of the variables we use, we would not include measurements or observations from people that have not climbed the mountain. We only care about whatever it is about the people that have climbed Mount Everest and made it to the summit. Variables can be two different types. They can be quantitative or qualitative. Quantitative means you have some way to give a value or a numerical measurement to it. Qualitative is you put it into a category or group. So some examples can be age. Age is a number, so it would be quantitative. Weight is a number, so that would be quantitative. Gender, for gender, depending on your study, usually you would think there's male or female, but now there are other genders as well, but all of them include in a category. No matter what it is, they're not numbers, they're categories. Same with nationality. You can be from France, you can be from the United States, you can be from Japan. Your nationality, again, is a category. Income, again, that's a number, so that goes to quantitative. So if you're in a category, you're qualitative, but if you're a number, you're quantitative. Population versus sample. Population is every individual of interest. Sample data is only some of the individuals of interest. So, as an example, using the Everest one, a population would be all the people that have reached the summit of Mount Everest. A sample data would be a randomly selected group of the people who have reach the summit of Mount Everest. We usually do samples when it's not physically possible or not reasonably possible to get all of the population, especially if you're talking about the world. You wouldn't look at all 7+ billion people in the world. You would just look at a sample of the people of the world. So it is important to know whether the data are population data or sample data. Data from specific population are fixed and complete. It's all of them. Data from a sample may vary from sample to sample and are not complete. So if you look at two different samples from a population, those usually would be different, but the population is all of it. Usually you want a population, but a lot of the times you have to get a sample because it's just not really feasible. So you may hear the word statistic a lot. However, statistic is only for a sample. So a sample statistic is the numerical measure that describes an aspect of a sample. But if you're talking about a parameter, it's the numerical measure that describes an aspect of a population. So statistic is just for a sample, but parameter is for the entire population. First example. The Hawaii Department of Tropical Agriculture is conducting a study of ready-to-harvest pineapples in an experimental field. So think of what the individuals would be in here. That would be pineapples. So then you could think, if the researchers are interested in the individual weights of the pineapple in the field, that would be the variable. The variable would consist of the weights. At this point, it's important to specify units of measurement and degrees of accuracy of measurement. So in this case, if you're dealing with weights, you probably want to be in pounds unless you're using a different unit, but whatever the units are in. Degrees of accuracy is essentially how many decimal places did you round to. Like, I rounded to 4 decimal places, or with 4 degrees of decimal accuracy, that sort of thing. The weights could be measured to the nearest ounce or gram. Weight is quantitative because it's a numerical measure, because there's a number. If weights of all the ready-to-harvest pineapples in the field are included in the data, then we have a population. The average weight of all the ready-to-harvest pineapples in the field is a parameter. So you're saying the average weight of all the ready-to-harvest pineapples in the field is blank, say 16 pounds. That number is a parameter because it's about the entire population. Suppose the researchers also want data on taste. A panel of tasters rates the pineapples according to the categories poor, acceptable, and good. Only some of the pineapples are included in the taste test. In this case, the variable is taste. This is a qualitative or categorical variable. So again, those 3 things, those are categories. So they're qualitative. Because only some of the pineapples in the field are included in the study, we have a sample. The proportion of pineapples in the sample with a taste rating of good would be a statistic. So let's say you had 67 out of 100 of them were rated as good. Again, that would be a statistic because you're just dealing with a sample. Levels of measurement: nominal, ordinal, interval, ratio. So we have categorized data as either qualitative or quantitative. But another way to classify data is according to one of the 4 levels of measurement: nominal, ordinal, interval, and ratio. These levels indicate the type of arithmetic that is appropriate for the data, such as ordering, taking differences, or taking ratios. So here are the 4 levels. The nominal measurement is about putting things into labels or categories or talking about names. You can't order any of these things, they're just categories. Usually when you're talking about qualitative data, most of it ends up in nominal. Ordinal level of measurement is things that can be ordered, but however, looking between 2 of them, it doesn't make any sense. So if you have a rating system of 1 to 5, you have an ordering. However, taking the difference between someone who got a 2 and someone who got a 4, it's just a rating system, so you can't really show difference there. It's pretty much meaningless. The interval level of measurement is stuff that can be arranged in order, but also the differences matter. Oftentimes, like, it's an interval, so it's continuous. A good one is time, because if you take the difference of time, you get the number of hours or minutes or seconds or some combination thereof. Next is ratio. Ratio is things where the differences matter, but also the ratios matter as well. You can divide these numbers and get something out. So whereas in interval I mentioned time, ratio could be number of hours something happened. So if I said one study said 2 hours and one study said 4 hours, I could divide those, and one study has half the number of hours than the other. So ratio is involved. Ratio also deals with what they call a true zero. So with that, if you deal with time, there is no like zero clock. However, you can have a zero number of hours, and that means no hours. So if ever you have 0 meaning no, usually you're probably delving into the ratio level of measurement. All right, let's deal with some examples. First one. Taos, Acoma, Zuni, and Cochiti are the names of 4 Native American pueblos from the population of names of all Native American pueblos in Arizona and New Mexico that I probably pronounced horribly. So with that, we are dealing with what type of measurement? Nominal. Because we're just dealing with names. All we're doing is looking at names. Can't be ordered in any way, maybe alphabetically, but it doesn't really mean anything. So when you're dealing with names, you're dealing with nominal. So you can't look at a name and say one is greater or less than the other. So ordering them is really meaningless. If you want to do it alphabetically, you can, but again, it's meaningless in statistics. Example 2, in a high school graduating class of 319 students, Jim ranked 25th, June ranked 19th, Walter ranked 10th, and Julia ranked 4th, where 1 is the highest rank. So this one would be ordinal, because you're ordering the data. However, differences don't have any meaning whatsoever. The difference between June's and Jim's ranks is 6, and this is the same difference that exists between Walter's and Julia's ranks. However, the difference doesn't really mean anything significant. For instance, if you looked at a grade point average, Walter and Julia may have a large gap between their grade point averages, where June and Jim may have had a closer grade point average. In any ranking system, it is only the relative standing that matters. Differences between the ranks are meaningless. Next example, body temperatures in degrees Celsius of trout in the Yellowstone River. So this one, you're dealing with temperatures and you have, it's continuous. You can have any decimal of temperatures. However, always go back to the 0 because 0 degrees Celsius doesn't actually mean anything. It's not no. So it's going to be interval. Because 0 degrees Celsius doesn't mean there's no heat. You can have negative degrees Celsius. So you can't say 32 degrees Celsius is twice as much as 16 degrees Celsius because there is no true 0. Or that 20 degrees is twice as hot as 10 degrees Celsius. Length of trout swimming in the Yellowstone River. This one, same thing, you've got any decimal can work, so it's definitely at least interval because it's continuous. However, if it's 0, then you have no length. So then you're going to be dealing with a ratio. Also, if you have a 6-inch and an 18-inch, the 18-inch is 3 times as big as the 6-inch. Just a procedure here. Nominal, putting things into categories. Ordinal, you're just ordering from worst to best. Interval is continuous. At this level, it makes sense to compare differences. And ratio, you can compare differences, but you can also compare ratios and making sure you have a true 0. And finally, descriptive statistics versus inferential statistics. Descriptive statistics is talking about something. So an example of that could be you look at a sample and find out that a certain percentage of people have blue eyes. So inferential statistics, you could then figure out many things about that. You could figure out what the percentage would be of a population, but you could also delve farther into that and figure different things out. So descriptive is just stating facts. Inferential is using those facts to figure out more. All right, now time for the sponge activity. You've got 6 questions here. I want you to answer them, and then I want you to take a picture of them along with your notes and submit it all to Google Classroom. So what we have here, just remember, if you get them all right, you get a bonus point on the next test. So, number 1, identify the variable in the statistical study, the one that says at John Berry School. Number 2, determine whether the statistical study is qualitative or quantitative. Number 3, determine if the statement is describing a population or a sample. Number 4, determine if the statement is describing a parameter or statistic. Number 5, determine the least restrictive level for the statistical variable. So which of the 4 levels of measurement would that statement go towards? And number 6, determine if the statement is describing descriptive or inferential statistics. That's it for the video. As I said before, submit everything to Google Classroom, and have a good night.